Everybody say hi to Samantha.
Hi, Samantha. What?
She's going to be watching this later.
Samantha.
Oh, Savannah. Did I say Samantha?
Yeah.
Oh, gosh.
I was so confused. Hi, Samantha. Hi, Samantha.
Hi, Savannah.
That's great.
Sorry, Savannah. I sometimes mix up names that are close to one another in the Rolodex of names that are in my head. You can throw an eraser at me when we're both here. By the way, Monday, since the trial will still be going on, I'm going to miss probably most of next week. Okay? So now, Monday, I will be here before school and during first period, but then I've got to scoot downtown to be down there at the courthouse by 10. So if you have questions, I'm going to try to be here each morning before school next week. I don't know for sure that I will be, but I'm going to try to be, because they don't tell us each day when the court's going to convene. Yesterday it didn't convene until 11. Monday it's convening at 10. Tuesday it may convene at 8 in the morning. I just have no way of knowing. Okay? So if you have questions, feel free to come in and see me Monday morning before school. All right? Okay. Oh, and also be sure you're bringing earbuds or headphones or something like that so that you can watch. I will have two things. I'll have a lesson video, and I'll also have a video of me going over the homework. It's not as good as getting your questions answered, but it's the best I can do. Sorry. Yes, ma'am.
Why don't they if it's something as important as a murder? Why don't they get a judge?
So part of our Constitution says that you have the right to a trial by jury.
Oh, that's what that means?
Yes, a jury of your peers, which means ordinary people. Okay, and the reason for that, at least in part, was, there would be corrupt judges where it was just one person. You could bribe that one person, and then, whoever had the most money got rulings in their favor. Yes?
I heard that someone, I don't know, some teacher here or whatever, had to go to a murder trial, and they were out for 3 months. How do you make money while you're gone? Do you just not get paid for 3 months?
So the way the law works on that is that your employer does not have to pay you when you're out for jury duty. Yes. But they cannot fire you for being out on jury duty.
So you're just not making money, but you also don't lose your job?
Well, it depends on what kind of a job you have. If you have a job like I do where it's salary, I get paid. If you're working an hourly wage job, you're probably not getting paid, and that really sucks.
Okay.
They do give us a little bit of money, but it's a little bit of money. I don't even know what it is. It used to be $10 or $12 a day. Thanks. I'll go get Chick-fil-A on the way home. And they feed us. They pay for our parking. So,
food and parking.
Pardon?
Food and parking. Pretty good incentive.
Yeah, I suppose. All right. So, today we're going to talk about measuring segments. I got to figure out what time classes are over. 11:15. All right. We should have enough time for this. We're going to fly through parts of it. So, the length of segment AB is written this way. AB with nothing over it. That's how we talk about the length of segment AB. It's my least favorite of all geometric symbols because people are like, what do you mean AB? That means the length of AB. I wish that they did there's one geometry book that I know of that does this. They put an M in front of it, like the measure of segment AB. To me, that makes more sense. It's also consistent with what we're going to do with angles, but it's what we're stuck with. I wasn't at the meeting when they decided this. That was a joke, friends. All right, so.
That was funny because you weren't at.
You.
She's mean to me.
Yes.
She's a mean person.
My jokes are hilarious.
I don't know.
All right. So is the distance between points A and B. Now, if these points are on a number line, This distance is the absolute value of the difference between the two coordinates. I know you guys have done absolute value before because, well, you did it when you were in my class. So, if we're finding the distance from A to C, we can just do the absolute value of -4 is A's coordinates minus C's coordinate is 3. So that's the absolute value of -7 is 7. Could you also have just counted the spaces? Yes. And that's fine if it's a short one like this. But what if A was at -58 and C was at 325? Yeah, good luck drawing that number line. Okay. Also, what if you miscount it? Then there's no partial credit. It's just wrong because there's no work to show. So this is how you can show some work. And so if you make a mistake, it's partial credit. So here, the length of CD, C is at 3, so I'm going to take the absolute value of 3, minus D is at 5. That's the absolute value of -2 is 2. Could I have done it in the other order? Yeah. I could have done the absolute value of 5 minus 3. That's the absolute value of 2, which is also 2. That's the bent absolute value.
For that one, wouldn't you just count, though, like, if it's, like, that close?
It's up to you.
Oh.
Yeah, if they're close together and you want to count, it's fine. But again, if you miscount, it's just all wrong. All right, BD, that's a little bit harder to count. So B is at -1.5. Minus D is at 5. What's -1.5 minus 5? -6.5. So this is positive 6.5. Let's see.
Difference mean minus?
Yes, difference means subtract. So for AB, I'm going to start with B this time. -1.5 minus A's coordinate is -4. Boy, there's a lot of negativeness going on that one. -1.5 minus -4. What's a simpler way to write that?
Plus 4.
Plus 4. -1.5 plus 4 is the absolute value of 2.5, exactly right. So this is 2.5. Any questions about that? All right, a new term for you, congruent. Congruent segments are segments that have the same length. So here, I tried to draw two that were at least close to congruent to one another, close to the same length. Notice there's two different things we're going to say. If the length of JH, remember when there's no symbol above it, it means the length of it, or the distance between the endpoints. The length of JH is equal to the length of TD. Then segment JD is congruent to segment TD, and this is the way we write that. Segment JH, this little symbol means is congruent to. Segment TD.
Is that just like a squiggly line with two straight lines?
It's like an equal sign with a tilde above it.
A tilde?
Yep. This is a tilde.
Isn't that what they put over like enye in Spanish?
Yes.
Okay.
It's exactly like what it is. And what it's to remind you of is this. Objects are congruent if they have the same size and the same shape. I like this symbol because the tilde reminds me they have to be the same shape. The equal means they have to be the same size. Okay? And I want to point out one other thing. Objects are congruent. Their lengths are equal.
Like a perimeter?
No, just length. So for example, if I tell you that my feet are congruent, that means two things. My feet are the same shape and the same size. There aren't because I crushed one of them, but that's a whole nother story. But are their lengths equal? Yes. So lengths are a number because you measure it. Those are equal. Objects are congruent. So like your hands. Take your hands, put them together palm to palm. Does one pretty closely, and please don't tell me about your deformities or how you jammed this thumb when you were in 3rd grade and it's bigger than the other one right now. Does one pretty much exactly cover the other one?
Yeah.
That's congruent. Your hands are objects. They are congruent. If your hands were perfectly congruent, then the size ring you wear on your ring fingers would be the same or equal size because that's a number. So numbers are equal, objects congruent.
Like pairs of objects or like any object?
Well, it has to be at least 2. You could have more than that. I don't have a 3rd hand, but, you know. Okay? All right. We're going to do a lot of things that are congruent. We're going to talk about angles that are congruent and triangles that are congruent and all kinds of other stuff. But congruent just means same size, same shape. All right. Moving on. So if a point is between 2 other points, all 3 of the points are collinear. So let's draw a quick picture here. If it's like this, here B is between A and C. And I tried to draw them so they were all on a line. Maybe you can do a better job than I did. Or maybe you could just use the lines on your paper. That would work, wouldn't it? But if it's like this, S is not between R and T.
So it's like not
Pardon?
collinear?
Because they're not collinear. For one point to be between, it's not sort of between, it's in a line between. Okay? Now, does it have to be halfway between? No. It can be closer to one than the other, but they all have to be on the same line. All right, page 2. The segment addition postulate. A big name for what is, frankly, a pretty easy idea. And a lot of words for something that's a pretty easy idea. So if a point is between 2 other points, then the sum of the lengths of the 2 shorter segments is equal to the length of the whole segment. You intuitively know this. That's part of why this is a postulate. Postulates are statements that we accept as true without any proof. We just go, well, yeah. I mean, if that's not true, then all of mathematics falls apart.
Wait, isn't there proof though?
Yeah, for that one.
Like you could,
For this, nope.
Couldn't you like
like
measure it?
yeah, if you measured it,
That's not proof.
Why not?
because numbers might be wrong.
Well, you've showed it's true for one case.
What if you just did
It has to be true. You're going to measure every segment in the universe?
It's like a lot of segments.
I'm going to give you a ruler and see you in about a bazillion years.
Isn't that like every single hair on every single person's head?
A bazillion? What are you saying? I don't understand.
Never mind.
Okay. So here, where R is between S and T, the length of SR plus the length of RT is equal to the length of ST. Right? The length of these 2 parts gives you the length of the whole segment. Then here, notice K is not in between J and L. If I add the distance from J to K and then the distance from K to L, will that be equal to the distance from J to L?
Probably not.
No. What would it be? Would it be more or less? Be more. That's actually called the triangle inequality, and we'll look at that a long time from now. Pardon? Only if it's a right triangle. But it's similar to that. All right. So let's do some example problems. We'll start off with something pretty simple and we'll work our way up to ones that are a little more difficult. First one, if J is between K and L, drawing a diagram is something that we're going to do a ton. And it doesn't have to be a work of art, but it says J is somewhere between K and L. Does it say halfway? No. So I'm going to purposely not make it exactly in the middle. J is somewhere between K and L. The length of JL is 16. So I'm just going to put that on my diagram. And the length of JK is 3.8. By the way, if JK had been longer, you don't have to redraw it and go, oh, wait a minute, this one's longer. It's fine. Now I want the length of KL. Well, the segment addition postulate tells me that the length of KJ plus the length of JL gives me the length of KL. So that's 3.8 plus 16 is KL. It's 19.8. Do you have to go through writing out the whole equation to do it? No, you do not. But again, if you miss it, it's just all wrong. Okay, I'm trying to show you ways to get partial credit. For this next one, if M is between P and T, so M is somewhere on the road from P to T. Let's put it closer to this side this time. PM is 3 3/4. PT is 9. That's this whole segment. Again, the segment addition postulate tells me since M is between P and T, that the length of PM plus the length of MT gives me the length of PT. PM is 3 3/4. I'm looking for the length of, well, they called it TM, so I'll go ahead and call it TM, is equal to PT's length, which was 9. I'll subtract 3 3/4 from both sides, and I'll have TM is 5 1/4. Again, do you have to write all that out? No, you do not. And seriously, no, you don't. I have nothing against someone who looks at that and goes, oh, I just need to subtract 3 3/4 from 9. That's fine. Just be really careful. Don't get it wrong. All right, last one in this section involves a little bit of algebra. Here we're going to have to write an equation. If there's an algebra problem and you don't have an equation, you don't get any credit for having done that problem. Don't care if the answer is right or wrong. Okay?
What if you did an equation, but it was like totally wrong? Like you didn't know how to do it, and you just like made up an equation?
Well, hopefully make up something with this stuff in it.
Yeah.
You do something that you think makes sense.
And then you like write an answer that was totally like just your guess from the start. That like wasn't the answer to the fake equation you made. Like,
that's a lot of thinking and working about fake stuff. Why not just do what you think?
okay.
Okay, so here, the segment addition postulate tells me that the length of AB plus the length of BC is equal to the length of AC. The two pieces added together give me the length of the whole segment when one point is between two others. So the length of AB is 13, the length of BC is 3x minus 1, and the length of AC is 6x. If you don't write that first equation, fine, but you got to write the second one, no matter what. From there, how much work you show is kind of up to you. 3x plus 12 is equal to 6x. So that's going to be 12 is equal to 3x, divide by 3. X is 4. And here's where another problem comes in. You spent so much time in algebra solving for x that occasionally people start celebrating at this point, but they're not finished. It says find the length of AC. The length of AC is 6 times x, so 6 times 4 is 24. That is your answer. It's an easy mistake to make, so that's why I'm pointing it out to you. Try to avoid that. Page 3. Yikes. All right. So the midpoint of a segment is the point that divides the segment into two congruent segments. The midpoint of a segment is the point that divides the segment into two congruent segments. So it's got to be between, and it's got to be exactly halfway between. So the two segments on either end are congruent to one another. And this is how we mark, I don't think I pointed that out earlier, this is how we mark congruent segments. We put a little slash across them. It's not super important for the problems we're doing now, but later on when we get to more complicated problems where there's lots of segments and these two are congruent to each other and these other two are congruent to each other, it's helpful to have a way to mark it. So here, y is the midpoint of segment RS. So let's do an example problem. It says that if J is the midpoint of segment RT, so I'm going to put J exactly halfway between, or at least as close as I can get, between R and T, and I'll go ahead and mark those congruent so I don't forget about it. The length of RJ is 6x plus 3. The length of TJ is 4x minus 11, plus 11. Since these two segments are congruent, I know that their lengths are indeed equal to one another. The length of RJ is equal to the length of JT. So that means then that 6x plus 3 has to be equal in length to 4x plus 11. See, that's going to be 2x is equal to 8, so x is 4. And they ask for the length of RT, which they didn't give you an expression for. But we can find the length of RJ. That'll be 6 times 4 plus 3. 24 plus 3 is 27. So that means the length of JT is also 27. And by the segment addition postulate then, RT is 27 plus 27 is 54. Last thing for today is a segment bisector. Your book drives me crazy occasionally. I know you were wondering what was the cause. But a segment bisector is any line that intersects a segment at its midpoint. Your book also says that a point can bisect a segment, which is fine, but why not just call it the midpoint then? They have this thing about calling, this point bisects the segment. Well, why not just call it the midpoint then? Why have a whole nother name for it? So here, if L is the midpoint of segment TM, here ray CD bisects TM at L. Or the other way around, if we know that we have a bisector, we know that these two segments are going to be congruent to each other. Definitions always work in both directions. Okay? So if you have a segment bisector, that point where it crosses the segment is the midpoint. If the point where the ray crosses is the midpoint, then this is the segment bisector. So a segment bisector is just something that touches a segment at its midpoint. Okay? Any questions about that? All right, your assignment is again out of the book today. You'll have your first worksheet Monday night for homework.